Hello everybody, we will talk today about an important topic for every physician, not only cardiologist, which is how to read ECG. Starting with this common scenario, 45-year-old male patient presenting to emergency with acute chest pain. To discover the nature of this chest pain, is it ischemic or not, we have different modalities, but among these modalities ECG is the one of choice because it is simple, rapid, cheap and available. So starting with background on our conduction system. As we all know, the electrical activity of the heart starts at the pacemaker of the heart, which is called the SA node in the right atrium. Then the depolarization wave travel among the atrial wall from right side to left side, then along the conduction system, his Precordial system to both ventricle, causing depolarization of both ventricles. The direction of conduction is from atria to ventricle, so it is downwards, followed by repolarization wave as seen here. So the electrical axis of the current of depolarization is moving from right to downwards and to the left, and this is important for the other slides. So how to record our electrical activity? Here is the ECG machine. We have 4 cables for the 4 limbs and 6 cables for chest. Where to place the ECG leads? We have the red cable for the right arm, the black cable for the right foot, the yellow cable for the left arm, and the green cable for the left foot. So a mnemonic: fire not seen, red and black on the right side; desert become green, yellow and green on the left side. But why the right foot electrode is not seen? Because actually this electrode is not recording electrical activity of the heart. It's just an act to remove the noise recorded with the other electrodes. So the functioning electrodes that record electrical activity are the right arm, the left arm and the left foot electrode. Then we have a chest electrode. Where to place the chest electrode? The first and second one are placed in the fourth intercostal space, one on the right side of the sternum and 2 on the left side of the sternum. Then the fourth electrode placed on the fifth intercostal space at mid-clavicular line just below the nipple. And the fifth and sixth electrode are placed also in the fifth intercostal space, but at the anterior axillary line and at the mid axillary line. The remaining electrode number 3 is placed between lead number 2 and number 4. So the idea of the QRS or the ECG picture from different electrodes are actually the same as capturing the same object like Eiffel Tower from different angle. For example, here we are looking to the electrical activity of the heart from the right side. In V1 and V2 we have a different morphology than that recorded on the middle of chest at V3 and V4 and on the lateral wall of the chest at V5 and V6, but all capturing the same electrical activity. So how the recorded QRS complex look at V6? V6, as we just said, lies here in the fifth intercostal space at the mid axillary line. So we are looking to the electrical activity of the heart from this side. The depolarization of ventricle takes 3 phases. The first phase is depolarization of interventricular septum, which takes place from the left side towards the right side. So the depolarization vector of septum depolarization is directed away from V6 electrode. Electric current moving away from the recording electrode cause a negative deflection wave on surface ECG. The first deflection, negative deflection wave on ECG is called Q wave. The second phase of ventricular depolarization is depolarization of the left ventricle and right ventricular free wall. But because the left ventricle is more muscular and create more electrical activity than the right side, so the net electrical current will be towards the left ventricle. And this depolarization vector of the left ventricle is moving towards the recording electrode if we are looking from this side, causing a positive deflection on surface ECG called R wave. Finally, the depolarization wave moves from the apex towards the base of the heart, a little bit away from the recording electrode V6, causing a second negative deflection on the surface ECG after R wave. A negative deflection after R wave is called S wave. So a negative deflection before R wave is called Q, and a negative deflection after R wave is called S wave. So how it looks if we are looking from this side at V1. Again, depolarization of the septum start from the left side towards the right side. So if you are looking from V1, from this area, the depolarization vector of the septum is actually here towards the recording electrode, creating a small positive deflection wave called R wave. Then depolarization of the rest of left ventricle. Here is the vector of depolarization is away from V1 if we are looking from this side, creating a negative deflection wave that come after R wave, which is called S wave. So the QRS complex actually, when we are looking from V1 is different from that recorded from V6 in morphology. V1 look like small r then deep S. In V6 as we just see, it is small q then large r and small s. So here is the ECG paper. It contains 12 lead, 6 recorded from the chest electrode, and this simple part of the lecture, and other 6 limb leads recorded through the 3 limb electrodes. So how these 3 limb electrodes, the right arm, left arm and left foot, give rise to 6 limb leads? This could be explained when we understand Einthoven triangle. So starting with the first 3 set of limb leads, which called augmented unipolar limb lead. Why augmented? Because the electricity recorded at the limbs are of small voltage. So the ECG machine perform augmentation for this electricity. So it is called augmented. Why it is called unipolar? Because it is measures the difference of electricity between this point, right arm or left arm or the foot, and an imaginary point on the machine called the 0 point. 0 point will be explained on the coming slides. So as we discussed before, that the direction of depolarization wave start from right atrium downwards and to the left, so it is away from EVR. So we are expecting that the QRS complex will be negative in EVR because the depolarization wave is going away from EVR. And another picture will be recorded through AVL, and a third one through EVF. So how QRS looks from unipolar limb leads, as we just mentioned, as it is going away from EVR downwards and to the left, so it's expected to be negative in AVR. And as it is going downwards and to the left on the direction of the left foot, so the left foot electrode will record a positive QRS complex, while that of the left arm is midway between both, because also the direction of depolarization wave directed to the left, but it is downward, and it is relatively away from EVL, so it will create a biphasic QRS as seen here. What about the rest of 3 limb leads? It is called bipolar limb leads, which simply records the difference between these unipolar points. So we have lead 1 that records the difference of electricity between right arm and left arm, and we have lead 2 that records the difference of electricity between left foot and right arm, and we have lead 3 that records the difference of electricity between left arm and left foot. So what is the explanation of this negative charges? As we just explained that the depolarization wave direction is downwards and to the left, so right arm is relatively negative in relation to the left arm, because the direction of current is from right to left, and also it is relatively negative to left foot, because the direction of the current is downward. So right arm is negative in relation to left arm and left foot. What about the left arm? The left arm is positive in relation to right arm, but it is negative in relation to left foot, as we just said that the current is directed downward, away from left arm. So left arm is relatively negative to left foot. Left foot is positive relative to both right and left arm, because the direction of current is directed towards EVF. So now we have 3 measured differences between 3 limb electrodes, namely lead 1, lead 2, and lead 3. So how QRS looks from bipolar limb lead? As we said before, lead 2 and lead 3 is on the same direction of the current downwards, so it will record a positive QRS complex, while similar to AVL, lead 1 is midway between the direction of current, which is towards the left, but the direction of the current is also downwards, away from lead 1, so it will create a biphasic QRS RS like AVL. So where is the 0 point? As we just mentioned, that lead 1 records the difference of electricity between left arm, which is positive, and right arm, which is negative. And lead 2 measures the difference between right arm and left leg. Left leg is positive and right arm is negative. And lead 3 records the difference between left arm negative and left leg positive. So if we sum lead 3 and lead 1, this will give this equation, which is actually lead 2, which is equal left leg minus right arm. Then if we calculate lead 3 sum of lead 1 minus lead 2, this will give the 0 point that we are searching for. So regarding localization using limb leads, lead 1 and AVL are looking towards the lateral surface of the heart, while lead 2, EVF, and lead 3 are looking on the inferior wall of the heart. What about the precordial camera or leads? V1 and V2 is opposite to the septum, V3 and 4 opposite to the anterior wall, V5 and V6 opposite to the lateral wall. To summarize the anatomical group, we have V1 and V2 septal, V3 and V4 anterior, V5, V6 and lead 1 AVL of limb leads looking at the lateral surface of the heart. Lead 2, 3 and EVF are looking at the inferior surface of the heart. And so we have explained the 12 lead appear on the ECG, 6 recorded from the 6 chest lead, and 3 unipolar limb lead, EVR, EVL, EVF, and 3 bipolar limb leads 1, 2 and 3, recording the difference between the unipolar one. When we are commenting on ECG, we are commenting on the duration and voltage of these different waves. So we should know the duration and the calibration of the ECG paper. Each small square here in the ECG paper equal 40 milliseconds. How this come? Cause the ECG machine printing on the rate of 25 millimeter per second. So each 5 millimeter equal 200 millisecond, and each 1 millimeter, which is one small square, equal 40 millisecond. So each small square of the ECG paper has a duration of 40 millisecond, and each large square, which contain 5 small square, will be 5 multiplied 40, which is 200 milliseconds. What about the voltage? Each small square equal to 0.1 millivolt. So each 5 small square forming a large square, so each large square equal 0.5 millimeter, and each 2 large square or 10 small square will equal 1 millivolt. The ECG machine print this caliber at the start of each ECG lead. This caliber height is about 2 large small square. This the ECG machine telling us that each 2 large square of the ECG paper equal to 1 millivolt. So the height of the caliber equal 1 millivolt. We have the usual calibration, which just mentioned, which is each 2 large square equal 1 millivolt. But we have the ECG machine have other option. If the recorded voltage is huge or large, like a patient with left ventricular hypertrophy, it is automatically change the caliber into what is called half voltage caliber, where each 1 large square equal to 1 millivolt. On the other hand, if we have a very small QRS voltage and we want to magnify it, we perform what is called double voltage, which mean each 1 millivolt will be drawn on 4 large square. So it is important before reading the ECG finding to look at the speed. The usual one is 25 millimeter per second, and the voltage calibration, each 1 millivolt equal to large square, and this is the usual calibration. Moving to the second part of our lecture,